Hello everyone, this is Bradley. Today this is a tutorial talking about a preset I made recently called a 3D viewer. So let's start. So here we're in Blender, and this is a very simple setup in which I have this cylinder and the UV sphere being instanced selectively on the points of this ico sphere. It's pretty straightforward, and the background information for me to create a 3D viewer preset is that sometimes we have vectors, but we need to visualize that in 3D space. So in this particular case, we have a bounding box. Okay, so it looks like we are creating a bounding box for every of these instances, which is very nice. But if you really output all this kind of minimum and maximum, you realize it's actually a solid line compared to the field, which is usually a dashed line. For example, the position attribute. Which means these outputs are not a field. If you hover your mouse onto this output, you will realize it outputs 0, 0, 0 and 0, 0, 0. It's actually meaningless linkages. These two outputs are not really working for the instances. What if you realize the instances and you realize it's actually calculated the bounding box of this entire whole group as a single mesh, so it no longer counts individual instances. So even if you put the realized instance at the back, it doesn't work as expected. Okay, so this is the background story. So I was making another preset which is called the instant bounding box, which is basically doing such a kind of function. But when I was working with these two minimum and maximum, if you try to take a viewer, I don't necessarily know if the value is correct. When I try to use the viewer, it just shows the kind of color, but I do not read the color as a vector. So if you look at the spreadsheet, it will just give you tons of values, in which I also do not really understand where is 0.140, 0, and whatever, so on and so forth. I don't understand a shit of that. So this tends to be a very huge question. That's why sometimes it's very important to be able to visualize all this kind of factor in a 3D space. And to implement this 3D viewer, it's very straightforward. That you just take all these kind of points node and the instance on points to instance kind of markers in the 3D space to show the result. So, and to use this 3D viewer, it's kind of very straightforward. You just plug that into the geometry, and now you can see a lot of markers are being generated. They are too large, so let's scale that down. By default, it's using the position attribute as a guidance. So you can see all these kind of markers are instanced on the position. The second rotation thing it's basically kind of using the normals attribute and align with vector. And that's basically the idea. But in this particular case, we do not really would like to visualize the position. We want to know this kind of minimum and the maximum. So let's plug this minimum into the vector. And I do not want to use this normal anymore. So let's just cancel this rotation by this combine XYZ. So now you can see this marker is too small now. Okay, so now you can see all these kind of markers are instanced somewhere, and I need to confirm if this is really the location of this bounding box. So the bounding box, let's just join geometry, because we want to compare that with the original bounding box of instances. Basically, the bounding box is basically all these kind of values are telling this left bottom corner and the right upper corner. And you can see right now all these kind of markers are at left bottom corner, so it's expected. If I plug this maximum into the vector, then they are expected to be on the right upper corner. So it looks like to be correct. So this preset is working with all this kind of math function inside to be working as well. I'm very happy. And with the 3D viewer, it really helps me to understand or to prove that's the usefulness of this preset. Otherwise, I will never know if numbers are correct or not. Okay, so it's very helpful. Next, I would like to discuss some design issue of this 3D viewer, because there are many other options being created, and I suppose maybe there will be more options being added in the future just for kind of a quality of life thing. I try to minimize this node, but it seems impossible. Anyway, so let's just start with a simpler example that I have this kind of curved circle into the geometry. And let's cancel everything. Cancel everything. Yes. So I have this kind of curved circle, which is working. By default, it's using the position attribute, so I have a marker on every point of this circle, which is also okay. And the view index, when it's negative, it means it's viewing all indices. But if you manage that to 0, then it will only tell you the vector at this point 0, and you can increase this view index to know where you're looking at. And basically that's the idea. Okay. And another thing is about XYZ, because this is very simple markers. Every part looks kind of the same. You do not know where is the x-axis, y-axis, or z-axis. Sometimes when you're working with rotation, you want to know the precise orientation of your geometry. Where's the x, where's the y, where's the z? So in this case, I have an xyz. When it's -1, it means it's showing all 3 axes, but you can choose the specific axis. 0 means x, so this is the x-axis. Y is 1, this is the y-axis, and the z-axis. So basically this is the idea. And the rest is just about the scale. The width is basically the thickness of all these kind of markers, and the scale is basically the length of all these kind of markers. In case you have a huge geometry that you probably want to increase the size of all these kind of markers, otherwise it's basically that. The last thing I would like to discuss is about domain. So let's start with a grid, and we take 3D viewers. Let's increase the amount of vertices and the sides. We can view all axes. So now all these called markers are placed on the position of points, as we've discussed earlier. And now I would like to view the UV map of this grid. So we take a named attribute, vector. Let's take the UV map, and we take a field at index. So we take a vector and the face corner and the index. Usually you don't necessarily to do this, but I'm going to do this for a reason. So let's plug this field at index into the vector, and you can see we're having kind of UV map being generated. This is indicating the UV map location, which is from the range of 0, 0 to 1, 1. But the problem here is that you need to recognize UV map number is always larger than the amount of vertex. By default, this 3D viewer is instanced on the point domain, which means the vertex of mesh, point of a curve, point of a cloud, and the amount of instance. That's basically the idea. But right now, if we were trying to work with a UV map, it will also show on the vertex domain. But if we are forcing this UV map to be shown on this face corner domain, then we don't have enough of vertices to show all the vectors. So we run out of it. In this case, we try to switch to the face corner domain. So you can see this kind of domain, it contains a point domain, and there is a face corner domain. Okay. So if you switch to the face corner domain, you can see all the vectors from this face corner, and you can try to use this view index to know how all this kind of UV map coordinate is actually distributed. Basically, the idea is a single face contains 4 corners, and it's supposed to contain 4 vertices as well, but obviously we are having overlapping vertex, so the vertex is not exactly 1/4 of face corner, but that's basically the idea. So in the future, perhaps this 3D viewer will change its design, but right now this is it. Okay, and I hope it's as useful as it's supposed to be. And if you find it useful, then it will be great. All this kind of preset can be downloaded for free from the link in the description. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.